Thanks everybody for joining us today. We've got a very exciting panel. I know everybody here is excited to learn more about applications of AI and the robotics space, and there's nowhere that's more obvious user of AI than autonomous applications. And today we have a really fantastic panel, folks who have been working in this industry for probably collectively greater than 50 years across this group. But I'm really excited to dig in and learn more and share some of those experiences with you all attending today. So before we jump in, a little bit on Peridio. So Peridio is a platform for software distribution and management of modern connected devices. We work with software teams at hardware companies who focus intently on building robust and secure distributed products. And we're very excited about applications like the one we're talking about today. Areas of refocus, just-in-time provisioning, flexible management of embedded software, cohort collaboration and distribution workflows, digital device management, secure remote access, and then lastly, providing a centralized source of truth for your operations teams so that as you scale, you always have that clarity and understanding of what software is where and who can access that in the field. All right, but that is not why you all joined. What we're here to talk about today is our webinar on autonomous systems. And I'd like to go now through our panelists. So Austin, why don't you kick us off? Tell us a little bit about yourself.
Hi, thank you, Bill. Thanks for having me. I'm Austin Deric, software director at Tailos, so responsible for all things software components on our product offering. A little bit about Tailos. So we're a commercial vacuum cleaning robot as a service company. We have a fleet of thousands of robots and hundreds of customers. And as a software director, I'm responsible for everything on robot. This is Rosie, our main product offering, commercial cleaning vacuum. We got some mechanical wheels, a roller, RealSense camera, LiDAR, touchscreen display, and an IMX8 SOM, the brains behind it all. So we run a ROS2 stack on our SOM, heavily inspired by Nav2, and contribute back and forth with them. We also have kind of a custom Linux Yocto recipe that makes us portable to various IoT providers. That's kind of fun. We also have a microcontroller on there, an ARM M6. I'm sorry, an M4. My apologies. I'm also responsible for the IoT platform that we use. Shout out to Peridio. Highly recommend them. And our simulation capabilities as well. Also responsible for cloud development. The source of that is we collect a tremendous amount of telemetry off the robot, terabytes and terabytes, hopefully petabytes soon. So kind of storing those in timescale databases. And that's really our crown jewels. We leverage that data in really remarkable ways. And by the way, if you're a data analyst or you geek out on data, these data sets are very fun to play with and do feed into the AI story. So we make that data, we kind of convert that data into value for our customers using our web application at app.tailos.com, our mobile offering, and then for our enterprise clients, we have API access and developer documents so they can integrate into their sophisticated data systems. We also use that data internally, so we feed that to our sales teams to drive sales. We feed that data to our customer success operations so they can monitor customer health and really maximize the customer experience, and also just kind of fleet, your tactical, fleet monitoring, health, robot diagnostics and things like that. So that's it for me. I count for 16 of the 50 years you cited earlier. So again, happy to be here.
Underestimated the aggregate. Yeah. All right. Well, thanks, Austin. Next is a repeat panelist, Shah from Simbe.
Hi, I'm Shah from Simbe Robotics. I'm co-founder and CTO. At Simbe, we build our flagship product, Tally, which is an autonomous robot that goes up and down aisles at brick and mortar retail stores, scans the shelves using high-resolution cameras, uploads all that data to the cloud, and then it's able to tell the retailer what's missing on shelf, what's in the wrong place, what has the wrong price tag, what's been moved around, and just a whole bunch of other information. And then the retailer is able to act on that data, to optimize their store, replenish items that are low or out of stock. Yeah, that's about it.
All right. And what is your day-to-day focus, Shah? All things technical?
Yeah, all things technical. I'd say primarily our software strategy tends to be my main focus because that is my main background.
Very cool. Thank you very much. Next, also from Simbe is Jari. So all things that Shah does not focus on. He has the luxury of working with this fantastic individual. So Jari, what's going on?
Hi, yeah, my name is Jari. So I'm the director of AI and computer vision at Simbe Robotics, and I basically lead everything to do with computer vision at the organization, which is twofold. So we have a computer vision pipeline that is taking these high resolution pictures that Tally is capturing in store, as well as depth data, and creating these structured views of the shelves that then can be used to drive things like, here this product is out on shelf, here this price is wrong, this is where the product is in a store, here's the most optimal path if you're picking these products for an order, and so on and so forth. And so I oversee the creation of that pipeline as well as the deployment of that pipeline to cloud. It's a hybrid pipeline, so we do cloud computation, but we also do computation on board the robot opportunistically. So there's a fair bit of edge deployment of AI models there as well. We do a lot of work with with the object detection, like visual recognition of products, OCR, and things like that. And then we also support the perception efforts on Tally, and essentially create these like light models that can run at a high frame rate on board the robot. And there's heterogeneous compute there as well. We have an x86 platform as well as a ARM-based computer, and so everything to do with weights management, conversion, making sure that particular models are optimized to run in particular environments. All that falls under my purview.
Very cool. Is there one on your desk as well? I'm just kidding. All right. And last but not least, Tom from Rapid Robotics. Hey, Tom.
Hey guys, Tom Hummel, CTO of Rapid Robotics. Been with the company for about 5 years now since its founding. Personally, I've been deploying automation going on about 15 years now. So my CTO at Rapid means, I do a lot of all the technical strategy, product direction, managing the overall technical execution. Now, unfortunately, the robots that we deploy, I can't really put on my desk, even though I wish, it would be a lot easier to work on them if I could. So Rapid deploys automation for end of line. And what we're really trying to solve is the adoption problem, trying to figure out how to drive volume and scale at a high velocity for 3PLs and manufacturing that have a very heavy logistics operation. So logistics for us means palletizing. It means putting things into a box. It means taking things out of a box. It means fulfillment. And it means just sort of, recombining, components that come in from a supplier, and then making more boxes out of those things. So everything to do with stuff going in and out of boxes, which sounds boring, but it's actually a very, very, very challenging problem. So the way Rapid likes to solve this kind of stuff is what we call practical machine learning. So we're very much of a fan of taking algorithms and approaches that have already been democratized and proven either in our industry or in adjacent industries, and being able to leverage those very, very quickly without having a huge team or a huge development time cycle and deploying those things. We're very deep into ROS2. I'm a big fan of ROS2. Our vision system is mainly powered by Zivid at the moment, looking at Luxonis, and we work very closely with Picnic and Dave Coleman with Move It Pro to do a lot of our controls. The way we see it as part of, on the algorithmic side and machine learning side is we really like to leverage zero-shot and one-shot approaches as part of our machine learning pipeline to be able to have our robots recognize things that it may or may that it has never seen before, which, when you're dealing with in logistics, it's pretty much every customer has unique things. And that's kind of what we're doing. So
And you also spend a bit of time on your Miata.
yeah, that's right. Yeah, so it's part of my my other hobby other than robots is building and driving race cars. I've been doing that with my dad since I was like 8 years old. So I have a turbocharged Miata in my garage right now that I race in SCCA, NASA, Sonoma, and Laguna Seca, and all that stuff.
We have a few folks I'd like to get you in contact with. A lot of folks in the IoT space, heavy in the cars. Yeah. All right, well, let's get into it. So for today, we've got really 3 topics that we're going to get into: the background and current landscape of technologies, build versus buy and autonomous, and then where does AI and LLMs fit in. We're going to have one panelist lead off each topic area, and then we'll just kind of get into it from there. And this is 1 hour, so we'll do about 15 minutes for each, and then we'll close it out. So let's go. So Austin, I really enjoyed some of what we'd talked about previously in this space. So I was wondering if you could talk a little bit to the background and landscape, like what's the formative technologies in robotics, maybe say a couple things about ROS, and then the benefits of the standardization around these tools.
Sure, sure. Yeah, we've already talked about ROS2 quite a bit. It is foundational for our product. We could not deliver our product to customers with our team size and with our capability set. It would take forever without really building on that foundation and using tools that are already created. And so the other really recent developments around next generation LiDAR, like some LiveVox 3D LiDAR, really low cost camera systems, and pairing that with, on the other side, the consumers of that, these AI systems are very exciting, and just driving down the costs on those things. And I think the cell phones don't get enough credit for driving down compute costs as well. So that's pretty nice. And
Explain.
in the few.
Yeah, what do you mean by the cell phones driving down compute?
Yeah, so largely our, before we had our compute system, it was largely like Raspberry Pis were it, if you wanted like low cost edge compute. So our product retails for about $3.99 per month. So we really have to be cost conscious, and to be able to run some of these higher level navigation things. We don't have the luxury of dragging a server farm behind us to do all our planning and image processing. So a lot of the cell phone technologies and getting that into the robot, just really high capabilities, and we could do very sophisticated stuff that wasn't possible before. And edge inference is definitely up there. And so really what we do is kind of use that, what's on a robot is really our constraints. And so, we build up our simulation framework to, run our software stack, thousands of times per day in different environments. And so a lot of the new technologies there are very exciting. Coming, I think NVIDIA has a huge robotics push that we're reaping the benefits of. Their Isaac Sims are very capable and impressive, and they spend a huge amount of money, and we essentially get new capabilities for free out of that. So we're grateful for them, and we hope they keep it up. We're very sad that AWS deprecated RoboMaker, but we're very excited about the future and transitioning on to new stuff. I think it's a sign of a good architecture when big service providers like AWS deprecate RoboMaker. In our kind of containerization approach, makes it pretty portable to go and run it locally, or even even NVIDIA's cloud, or their new batch service. So you always got to stay on the leading edge, so you can handle these unexpected things and keep delivering features to our customers.
So with all the standards that are in place, and this can be kind of open for the group, where do the teams end up having to focus? So it's not just pure robotics applications. Yeah, so like maybe what Simbe, where are you guys really having like the primary of your focus area for providing value to your customers?
Sure, I can jump in on that. So, as Austin mentioned, ROS, the robot operating system, what ROS enables is it allows us to kind of work at a higher level of abstraction and not have to deal with things like drivers for hardware like LiDARs, or algorithms for doing navigation and path planning. you don't have to re-implement algorithms like A star, and you can kind of focus on your actual, business application. And, for like in the example of Simbe, making a robot that runs, 7 days a week, 365 days a year, super robust. That's very challenging. Even with all of like the navigation and drivers and stuff. That's once you get past that, making something that's battle hardened, that has to run every day. That sort of becomes the main focus.
And Tom, I think you like Tom. For those of you that don't know, so Simbe and Tailos are more like rovers around stores or commercial areas, and then Rapid, you all are working in like a logistics, often always on scenario. So how does this apply to you?
Yeah, I mean to echo, it's the same thing, right? It's I echo things around ROS too. It gets you to that application, way faster, right? You're not having to create boilerplate code or algorithms that already exist that are 50 years old, right? Like it should just be there, and you want to focus on your end. For us, like where we spend a lot of our time, isn't so much, on the control, even on the perception side, I mean, we'll talk about that later, but it's, it's highly democratized at this point and straightforward. The thing now is robustness, right? So for Rapid, our customers cannot make money unless our system is online, right? So we are directly involved into the operation, for example, of our customer's warehouse. So they cannot ship components to their customers, right, if our robots are not handling those components. So downtime for us isn't just about our bottom line, but it's also about our customers' bottom line as well, which increases the bar, right? Like it's like 99.9% uptime is not good enough. That's not acceptable. It has to be 99.999% uptime. And if something does go down, Rapid, is something that we pride ourselves on, that we do very well, is we are able to support that immediately, right? Within hours. So we make sure that we have support technicians strategically positioned across the country, in order to have a rapid response, pun intended, to be able to, support our customers, because they will pull us out, right, if we're the bottleneck.
Very cool. I enjoyed that pun very much. I'm sure that's not the first time you've
4 times, but I'll try to stay away. But
so is this sharing now? Let's see. Yeah, so decent segue. So in thinking about these systems, you are needing to invest in your core IP and leveraging off the shelf wherever possible. I think, Tom, like, how do you guys think about this build versus buy and the autonomous space?
Yeah, it's kind of like this thing where it's kind of all on its head. I would say it's changed in the last maybe 2-3 years. Is that traditionally, when you start create a robotics product, at least in the space that I operate in, mobility is a little different. You kind of have to, build your thing. But traditionally for manipulation, you would buy a robot arm, from UR, ABB, FANUC, whatever. And you would buy components from McMaster, Automation Direct, like any of those things, I call it catalog engineering, right? Like put it all together. You have your hardware platform, and then you really focus your innovation and iteration on the software side. Like all your IP is going into that front. What I've seen or I've observed in the medium term history is that the tasks that in manipulation for off the shelf robotics have kind of been tapped out, right? Like it's kind of everything's already been done. I mean, it's a bold statement, but it's kind of 90% of the things have been done, I would say, that off-the-shelf hardware could feasibly service with whatever software, right? The problem that we're facing is even if like we could, a lot of companies can now handle anything, really. I mean, like pick and place anything, that's not really the problem anymore. The problem is what's the ultimate cost and time of delivery for the actual solution? And we've seen that the main bottleneck now in the manipulation space is the hardware. So when it comes to build versus buy, we're actually now buying or partnering or adopting software that already exists, and we're just doing, you know, what we need to do on the app side, the model training side, the data side, you know, to be able to make that work for us. But but on the hardware side, now we're in the situation where it's like, okay, if we really want to solve this adoption problem across this industry, it really needs a new form factor to be able to do that. And that form factor doesn't exist, right? Like the robot manufacturers are not servicing this problem, right? So now it's kind of like flipped on its head in terms of this build versus buy across hardware and software for manipulation. Mobility, and the other guys definitely would probably agree with me in that, like, you can't just buy a robotic vacuum cleaner, right? With software on it. And that's always been the case. So.
Is that yeah, Austin or Shah, is that a shared sentiment, or like where are you guys seeing
I think it's a little bit different for us at Simbe. So at Simbe, as Jari was mentioning yesterday when we were having our conversation, we own our entire stack from top to bottom, all of the hardware, all of the software. And for us, that's because we believe that everything needs to be vertically integrated to work really well together. You know, you can't, you know, a lot of people try this approach where, you know, one company will build a robot and another company will build the computer vision software, and they'll try to just like slap the computer vision software onto this robot that wasn't necessarily designed for that particular, you know, application. That just doesn't work. We've seen it happen over and over again, folks who try to enter our space, and it ends up being a failure. And, you know, a popular example of like a well vertically integrated company is Apple. You know, why are their products so beloved? And it's because everything just works together. Your iPhone works with your MacBook, with your Apple TV. The interfaces are consistent across everything. It's a unified experience. The same thing happens with us. The robot, our computer vision software, our UI, our web UI, our mobile application, all of that, we own all of it 100%. Obviously, we didn't invent everything in-house. You know, we depend a lot on open source, but at the end of the day, we own everything from end to end. Jari, you want to add something else?
Yeah, like speaking of our website, you know, that's actually a really good example, because to build our neural nets and, you know, detection models and OCR models and all that kind of stuff, we didn't even go out and adopt like an existing annotation platform. We ended up building our own that's integrated fully with our website, and we contract with a company that does a lot of different kind of robot monitoring related tasks for us, and they also they started providing us with the annotation service as well. And that just ended up being significantly superior to other solutions that were out there. So we were looking at this back in like 2016, and everybody was like, hey, we just use Mechanical Turk. And we're like, we can use Mechanical Turk, and in that particular scenario, it's cheap, but we can build something ourselves and it's a little bit more expensive. We can overall make it relatively cheap still. And what we end up with significantly high quality data. And so time and time again, we've looked at the build versus buy question, and in, I would say 99% of the situations, we found that building is more painful in the beginning, but it ends up paying dividends later on because of cost considerations, or you know, we're able to make all of the cloud components, for example, very, very cheap. And I don't think we would be able to do that if we were, you know, partnering with another company to provide like a piece of the solution.
So Tom, with what you guys are doing, needing 99.99 critical infrastructure, how do you go about evaluating vendors and partners and these other like offloading critical software?
Yeah, I mean, it's a really great question. So I make a comment. I mean, like it's build versus so build versus buy is more like build versus buy versus adopt versus partner, right? Like, so it's like ROS 2, I consider that a buy, right? It's not going to pay money for it, but you're also not writing a new robotics platform, right? You know, if you download a model like YOLO from Ultralytics or something from Hugging Face, right? Like that's still a buy versus like a build, right? In the way I see it, right? Like you're not having, you know, senior ML scientists. Like gone are the days, I think, where you have senior ML scientists creating fundamentally new neural net architectures, right? Like that's what Facebook is for, and Google and Microsoft, right? Like they're the people that can afford to actually do that and make it work, right? Unless I'm wrong, which I could be. I think that in order to evaluate partners for reliability, it's about reputation ultimately, right? You need to be able to have you need to be able to trust your partners that they have delivered, you know, functional systems, you know, at scale for a period of time, right? So for example, Movement, right? So our motion stack right now is powered by Movement Pro, right? Movement Pro is from Picnic, which was founded by Dave Coleman. Dave Coleman was one of the original authors of Movement, has spent his entire career in that stack, and, you know, has worked with, you know, thousands of robots likely at this point, NASA, DARPA, you know, the whole thing. So I trust the code that his organization creates, right? Because they're solving a problem that I don't view as core IP for Rapid, but the integration, of course, as Mirza mentioned, is extremely important for the ultimate customer experience, right? Because the customer just wants a problem solved and they don't want to have to look under the hood, right? And you know, it's also about testing and qualification, right? Like at the end of the day, the rubber has to meet the road, right? Like you have to be able to put your robot through its paces and try and test every single edge case. Ultimately, right? Like you're never going to get to 100% reliability. It can be difficult to do accelerated, you know, MTBF testing for highly integrated systems like this. So that has to be backed by an actual on-site post-deployment support model as part of your business operation, right? Like that has to be costed in, that has to be staffed, right? And it has to be managed, right? In order to do that. And that's really what the customer wants, because the customer also knows that automation breaks. So what they want to know is, okay, when this goes down, Rapid, what are you going to do about it, right? And that question has to be answered.
And so when most of the software that you're running from your partners, would that all be real time, or are you leveraging anything cloud oriented?
It's both. I mean, every robotics company is actually a cloud company, right? Like, because just the sheer amount, especially when you have data-driven solutions, like lots of machine learning, right? Like that is a must. You have to have a very professional, you know, scalable cloud function as part of the business. Of course, the robot running in real time. I mean, yes, right? Like, so Rapid's technical structure as part of the engineering teams is mainly divided into edge and cloud, right? So edge is like robot control, on edge perception, right? Like actually having the physical hardware do the physical thing. And then cloud is about fleet management, data aggregation, data annotation, and anything to do offline.
Got it. Austin, anything to add on this topic?
Funny. We split our teams as well on that basis, like your C++ Python devs versus your JavaScript devs. Though I do see LLMs actually affecting that quite a bit. I mean, we use ChatGPT heavily, and you know, the C++ devs could be dangerous writing a JavaScript code. You know, it's fun to see them do that, and they can contribute.
I'm terrible at JavaScript, so.
Yeah. But I do find it interesting, you listening to this, that, you know, I think a lot of our stacks are probably very similar. You know, we share a whole bunch. And if we were to all do that separately, it would take many, many months, hundreds of thousands of dollars. And really, when you're a startup, that's life or death. And I also think that, you know, it makes it easier hiring as well. Like I would bet that we could take any of our devs, give them a Jira ticket from the other company, and they can contribute within a day. I'm pretty confident that's the case. So it's really exciting to see. We have very lean teams. So we largely buy as much as we can. You know, Nav2 has been awesome. But yeah, it's not a product. Like the difference between a product and like, you know, maybe a grad school or an open source repo is very different in terms of, I think, reliability is harped on. So we test the heck out of it. We find the bugs and we find features we need. And so we kind of contribute back to the community. And, you know, we do that. And, you know, some people in this call could, use those features and that increased reliability for their own benefit. So it's really awesome to see like just the collaborative nature of open source robotics and how it's all, helped us be where we are right now.
You mentioned the LLM, so we can go ahead and kick over to that. Really excited to hear where we think that this all plays together in the space. So we're all seeing these fancy videos from Tesla and Figure and these humanoid robots and interviews with other executives that are saying that given AI, coding is now super easy, robotics are solved problem, and really curious, where this group feels that these next generation technologies actually fit in, and if if it is going to be that next big unlock, or if it is just more components to building the new robust systems. So, Jari, I think you had some pretty good points on this yesterday. I would love it if you could kick us off and lead this conversation.
Yeah, sure. So a lot of the current hype around LLMs and Gen AI, there's a lot of real hype, and then there's a lot of kind of, I don't want to use the word fake, but it's, there's more to it than what meets the eye. And so there's this perception that with something like, a vision LLM, you could solve the perception problems without having to deploy, like, let's call them old-timey object detection models, or that kind of stuff. Like, visual problems can be solved now with the LLMs, so we don't need to train them anymore. We can just start using LLMs. And that's not quite true, at least at the moment. There's a version of the future, let's say a decade down the line, where that could actually become the case. But right now, LLMs and vision models are really useful for either being last mile kind of solutions. So moving a little bit away from robotics for a second and talking about the computer vision pipeline that we run at Simbe for analyzing retail images. We have spent a lot of times optimizing and creating these like really small models that have extremely high accuracy, and they're very task specific, and they work extremely well, and they don't cost us a lot of money to run, but they will sometimes miss certain things, right? Like we go into a new environment or something changes in the environment, and all of a sudden we're starting to see an error that we weren't seeing before. And we found that some vision LLMs like GPT-4V can be a really good kind of last mile solution where we're running into a problem, finding a solution to a particular visual problem, and GPT can help in those cases where the internal model fails. That's one place where they're very useful. They've also been very useful for annotations. And so a good example would be OCR related annotations in very specific environments where we don't have data sets. Let's say we onboarded a new customer and they have price tags that are written kind of a funny way. We found that LLMs tend to be really good at reading that price, right? And even though they're not doing explicitly what one might consider OCR. And so that ends up becoming a really useful mechanism to do annotations and creating thousands of examples for training what is ostensibly a traditional OCR model. Yeah.
So are you using any of this in real time, or is this more after the fact research one-off?
It's after the fact or one-off. So there's a good example might be that I'm creating a report for a customer that includes a list of all the prices that we found to be incorrect in a store, right? This is something that we do multiple times a day. So we can improve that report's overall accuracy by giving it a second pass through a more expensive vision model that we only have to run on a very small sample set in this case, as opposed to every single price tag that we encounter. So those are, I guess you could kind of consider them online, but they're not, online on board a robot. They're not real time in any meaningful way. I know there has been some work in like policy selection or figuring out what the robot's next task should be. That would be online, or at least maybe potentially are using an API. But we're not doing any of that at the moment with LLMs. I think robotics as a whole is not going to get there for probably at least another decade until compute catches up, or some of these LLMs become small enough to to be more feasible, not necessarily to fit, because an NVIDIA Orin or a Tor can more than likely fit a pretty reasonable LLM in it. But the question then comes, what else is going to be able to fit in addition to that?
Tom, what are you guys doing? I know you talk a lot about generative on these applications.
Yeah, absolutely. So we have this like super like we live in this like super high mix world, right? Where it's in a super fast deployment cadence where we have this thing where we have to be on site, with a customer that we've never met before within say couple weeks, right? So that doesn't give us a lot of time to train. Right now, we're leveraging 0-1 shot, so which are basically promptable models, either with an image or text. Right now, we leverage them more in the training situation where we can say, hey, like, get all these images, automatically annotate right with one of these 0-1 shot approaches, and then train a like a YOLO or a one former or something around that. Right. We are doing active work in order to determine the feasibility of actually deploying those models on a production basis. So one of the main bottlenecks, well, there's two main bottlenecks for us that we're working on right now, is the consistency, right, of that, and then also the inference time, because these models tend to be a little bit more beefy, and we're not running on a fully embedded system because we can plug in, and we don't we don't have big thermal or weight or power requirements, so we can run a pretty beefy PCI Express GPU and effectively a desktop or industrial PC, but it's still our inference times have to be around half a second, right? Most of these LLMs infer probably as fast as like 1 to 2 seconds. So it is a problem for us. For the tech space, text to text, like your chat GPT kind of stuff. I mean, yeah, all our developers utilize that. I think that's like table stakes now as far as its utilization over there. We are doing also some research as part of our new product that we plan on releasing next year, where leveraging the LLM to rapidly customize the application for that product, and to be able to adapt it for different customer scenarios.
Yeah,
So where is I mean, there is a lot of hype right now and a lot of excitement. So what is justified? Like where is the promise and the excitement? Is it getting these products to market more quickly, the quick training, the quick evaluation of an environment? Like where are you guys most excited?
I think really go ahead.
Fast deployment is kind of like what we're excited about.
Yeah, really quick turnarounds on things. I think those are becoming more possible. There's also, so the slide I believe said LLM and Gen AI, and there's a whole class of new advancements that wording maybe in the minds of people does include, but I feel like it kind of neglects. So there's parallel advancements that are related to language models. So a good example of that would be text-based pre-training of vision models that, in the form of something like Clip, which is very useful for things like one or few shot detection or being able to do visual recognition of things. It's kind of like parallel to LLMs. It's not a generative model. It's not something that we think of when we think Gen AI, but it's been absolutely fantastic for being able to quickly turn around on things, being able to find rare events in our data sets. It's really useful for, or being able to find visually similar kind of situations so that we can, create hard training examples faster. Similarly, something like segment anything, SAM models, those have been amazing for video annotation and just, decrease the time of something that would normally take us a day to do to just an hour or something like that. So there's a lot of other stuff that's also happening in the space that isn't front and center in the hype, but is actually advancing things more concretely than something like LLMs or vision models are.
Is there any justification or capability of using these systems on like early POC deployments and just a completely cost ineffective model, but just running it in real time on the edge?
I think there could be. I was going to say earlier when Tom was talking, like the tyranny of battery, right, is what we suffer from at Simbe and at Tailos. But in a situation where you don't have that problem, or if you're just trying to demonstrate a few things, you could run significantly larger models. If you're doing a PSE, you maybe don't even have to worry too much about latency, because you can argue that latency will go down over time. This is a research thing, yeah, for sure. But there is, so that's another kind of perception. There also this question comes up often. If we've been building these systems for 8 years, right? For Simbe Robotics, we have a bespoke computer vision stack that does the things that it does really, really well. We have models they're optimized to do one very specific task, and then somebody could, in theory, come along and use ChatGPT and their API, or like even something like really small, like a 3.5 billion vision LLM that works quite well on a lot of visual tasks. They could build a big chunk of our stack without needing a bespoke model, something very similar. They could do that. I did a back of the envelope kind of calculation to see if somebody were to do something like that, what their cloud costs would be. And it was roughly 30 times more than what our cloud costs are. So, it's one of those things where if somebody's doing a proof of concept and they're showing that, hey, we can do the same things as this other company, or we're building a new business, it's possible, but they're going to have to come off of that very, very quickly if they're going to be able to, show that they'd be profitable.
Yeah, I mean, maybe it's just these monsters, Google, that have, they're like, let's get something built, get it to market, but they don't have to worry about money or batteries.
Well, and things are decreasing as well. I think one of the more surprising things, GPT-3 was very surprising, right, in what it was able to do. But at the time, it was very obvious that it was going to be this like big power hungry beast. And one of the most surprising things that happened in the 4-ish years ensuing is that we've seen that there are techniques to make significantly smaller models work just as well. So we have like 7 billion parameter models that are doing way better than GPT-3 was back in 2020 or whenever. And so there's this sort of straight line that we're currently seeing in capabilities becoming more and more accessible and requiring less compute. It's just that even I mentioned Phi visual LLM before. It's a 3.5 billion model, and like that's tiny in the LLM world, but it is orders of magnitudes larger than an OCR model that I might deploy to read prices. So there's still a big gap, but it's shortening. It's becoming smaller.
We have a couple of questions from the audience. One, what about the future of intelligent sensors, in-memory computing, and improvement on edge apps? Is anybody here evaluating that?
I'll take that one. I think this was intended for like maybe cameras with like maybe AI chips attached to it, and things like that. So you don't really get the frames out, but maybe you get like the more semantic, more reasoned observations of the camera out. But I'll take that question more generally in that our robots, I really do consider our robots like sensor systems themselves, fully integrated with edge compute. So it really does change the game there, and unlocks a lot of possibilities. And putting my developer hat on, it opens up that solution space to things that weren't possible before. So I think of looking at the generative AI space more. We put into kind of 3 bins. Like, okay, we can clean up maps, semantically segment them, analyze them, present those to customers in ways that they would understand. I think that's very similar to what Simbe does. And then there's things like, the transformer, I think it was Google Robotics Transformer 1 and now 2, which they haven't open source yet. I hope Google's listening and does that for us. And then the third one is actually probably more exciting to talk about, and just more impactful for the end users, is that, it right now, maybe pre-LLM, the way to interface with robots was really, your tablets, your desktop computers, you might have a touchscreen on the robot, whatnot. And that was really limiting into what you were able to do and impart with the robot. Imagine a future where, you have your fleet of robotic cleaning robots out there, and, you're just having a conversation with them and they're talking back to you. Oh, hey, I just unlocked this door. There's some debris on the floor over there. Can you go get that real quick? Or, I need you guys to go clean floor number 2. And then, or they say, hey, there's a spill. Somebody spilled some, champagne after a long night of partying on the floor. Can you clean it up? So I really do think it unlocks the next generation of just how we interface with robots. And then from the LLM's perspective, it really does. Robots are a vehicle to increase capabilities. Right now, it's largely, you put text in and it gives you text back, and that's great. And you can copy and paste it and do whatever. But now LLMs will be able to actually go affect physical things in the future, cleaning floors, restocking, helping out, picking up things. So it really, I think there will be a lot of robotics use cases in the future, which are really, we haven't seen before, and just based on what LLMs are able to impart onto the world. So very exciting.
Awesome. Thank you for
Yeah,
that.
I'd like to, I'd like to
Yeah.
add to that. Yeah, so roboticists, we love smart sensors where processing, is done on board, because when that processing is done on board, then we don't have to do it on board our, main computer. So an example that, Austin was talking about, the RealSense camera. We also use RealSense cameras at Simbe. We actually have 16 of them on Tally. And, I'd say most of our CPU is dedicated just to processing the data that is coming off of these real sensors. We have to run a series of filters and things like that to, clean up the data that's coming out of it. And then we're doing all this post-processing. If we were able to do that on board the sensor itself, it would save us, immensely. And one of the trends in the world of ROS is people are now starting to develop sensors that can directly talk ROS without, so you're basically creating like driverless hardware. And yeah, we love that. We hope that trend, continues. And folks continue to build smarter hardware that just works out of the box.
Yeah, I think in the camera space, since cameras were mentioned initially when this came up, in the camera space there is Luxonis. That's, I think, fairly well known. They built their camera systems on the Intel Movidius chip, RIP Movidius. But we've evaluated some of those cameras, and I think things like that have a big opportunity to shake the whole system, right? Because one of the things that we do at Simbe Robotics is we're capturing these very high resolution images, and then we're running a number of neural nets on them to make them smaller so that we can save on bandwidth, because retail stores tend not to have very good internet. And we built a system that can save 75 to 80% of the store's bandwidth and still keep all the salient data in the images, but that requires edge compute, right? And that edge compute is now happening on board our Intel NUCs or our NVIDIA TX2s on the robot. And these cameras can also do it, right? So there's this interesting future where, in theory, as soon as the picture as soon as the camera takes a photo, it's already run like 3 or 4 neural nets on it. It's done the compression. It's gotten all that information out. And then it's also super useful potentially for navigation, because now your camera can already tell you that you are looking at a shelf or you're exiting an aisle and all that kind of stuff. So there's all these tasks that can happen on board a camera on a relatively lower power chip, which also in theory frees you from the tyranny of the battery, right? Tries to decrease the power draw and that kind of stuff. So there's some really, really interesting stuff happening in that space that I think can shake the industry quite a bit.
One more question from the audience. Has the panel heard of investigated active inference? Is this a new term? No. All right. Easy.
Yeah, but now look it up.
Yeah, cool.
I
All
can
right.
Google it.
A short answer, no. But very cool. All right. Last one here. This might be kind of a fun softball. How do we see the market shaking out? There's a ton of massive titans, Tesla, Figure, Apptronic, and many vertical specifics. Do we expect folks to merge? Do we think others will just fade away? I mean, it seems like that the industry leaders are investing heavily in this space. And I I mean, clearly Elon's getting a lot of attention because that's what he does. But yeah, what do we see? Tom, I think you've probably got a smile that has some answers
Yeah,
here.
I mean, of course I have opinions, but it's more how do I? So in my space, I kind of see it is going through a very profound shift. A lot of like that relates to the build versus buy combo I mentioned earlier, where you have what I like to call the pioneering robotics companies, right? The plus ones, the Kindreds, the right hands, Saros, the sort of like you have a work cell that picks and places a thing, right? We see sort of like those companies achieving like have hit kind of like a scale cap in terms of their ability to grow beyond where they are right now. A lot of them were founded between 2014 and 2017. So they've been in business for quite a long time. And so they're very much married to a very specific way of tackling and solving that problem. And what we've seen in the industry is that scale just hasn't panned out. The way that it was originally expected. I mean, that's just the harsh reality of the situation. And what we see now on the humanoid side is interesting. My personal view on humanoids is like it's a very, very cool demo. I think it's a very long way away from a true humanoid robot. Actually adding value at scale in logistics, in manufacturing applications. There's other applications certainly. But what I am very bullish about, from the market is that these humanoid companies are pioneering this sort of like having the correct hardware that is easily deployable and working within hours of deployment. That's the real game changer from like the humanoid architecture. So, from putting my sort of solutions engineer, roboticist hat on, when I go to a facility, the first question that always gets asked, after the customer says, I just want to put a robot there. Just put a robot there. The human's doing the thing, put a robot there, done, right? We know it's not that easy. So when I look at that, I'm thinking, well, what robot arm should I use? Where should the robot arm go? Do I need 2 robot arms, or can I get away with 1 robot arm? And then it ends up being this, what I would like to call an installation, right? Like it's not a robot, it's a machine, it's an installation, right? Humanoids have solved this problem naively, but they have solved this problem in the sense of like they can actually go and answer that question when the customer asks, I just want you to put a robot there, can you do it? They can actually say yes, right? Like, and that's the key game changer. Now the factor is like, okay, what about performance? Can this thing actually perform at the speed? In my industry, UPH is king, units per hour. Throughput is everything. If you're not as fast or faster than a human, forget about, yes, all the other intrinsic benefits of data and reliability and whatever. All they care about is speed, total facility throughput. And so you have to make sure that you're not the bottleneck there. Humanoids are not there yet in terms of their overall performance. I think a miss in the development is they're going after very much generalized robotics across a variety of on ill-defined tasks, right? The idea, for example, Figure, when I talk to my friends there, they don't have a product or sales team. Why? They say they don't need to, because they're building a human. If a human can do it, then the thing automatically sells, right? We know, practically speaking, that's a pretty long scale bet, right? In practical terms, when I think about, but practical robotics, right? Robots that make money. We need to be able to say like, hey, okay, there's attributes of this thing that, lend itself to be very disruptive and very evolutionary for our market. But we don't have to build, full Android in order to do that. We can, so I think in terms of the market, I think you're going to see companies taking aspects of humanoids and create what I would like to call an internally integrated machine or robot, right? Versus the sort of like work cell, buy from Fanuc, buy from ABB, get a bunch of extruded aluminum, right? Spend $150,000, in conveyance, right? To like make this thing work. It's something that's fully integrated, can be deployed within a day, and then can evolve, right, with the customer's operation, right? Because again, in the logistics and manufacturing space, operations are living beasts. They evolve over time as the customers evolve their processes. So they need automation that can evolve with them, right? And that's kind of the key thing that I've observed.
That seems like
Yeah.
a really great. Oh, sorry. Somebody else have any
Oh,
final thoughts? 1 minute
yeah, I
left.
was going to add to that separation between what is cool and what can make money is I think Chef Robotics is an excellent example of something that you could imagine, you know, a task automation that you could imagine a humanoid robot doing. It's food preparation. It's meal, you know, meal kit preparation. But it makes so much more sense the way they're doing it, which is through essentially an assembly line and a bunch of different arms, and they're focused on creating the right graspers and creating the right neural nets in order to be able to identify how to grasp particular types of food, so that they don't have to do any bespoke deployment for, you know, different kinds of environments. But it's still a machine, right? It's not a cool humanoid looking robot. It's a job that's typically done by people. And in theory, you could have a humanoid robot go in and also do that job, and you could buy, you know, 20 humanoid robots to do an assembly line similar to how people do. But that machine, the way they're building it, is arguably better and cheaper. So that, you know, that's essentially the difference between, as Tom was saying, what is cool versus what makes money. Yeah.
Yeah, maybe have the humanoids install the later installation.
Figure is over $600 million. So I mean,
which yeah, cool does get you funding. That is true.
But someone's going to make money for sure.
But yeah, what they're doing is amazing. You know, what Figure is doing is amazing. But it's a question of where does that going to actually end up in terms of being valuable to society. I bet there's a path there. It is going to be useful, but there's still room for, as Tom said, machines.
Yeah, the practicality is still many years away. Yeah. All right. Well, I think we're at the top of the hour. Thank you everybody for joining. Thank you to the panelists for fantastic conversation. And yeah, stay tuned for our next panels on application development on the edge. So thank you all and have a great day.
Thanks, Bill.
Thanks, Bill.